area and volume. When considering three-dimensional solids, we can talk about area, surface and lateral, and volume. So there's two types of areas we're going to be talking about, surface area and lateral area. We can think of area as the amount of wrapping paper it would take to cover the object if there were no overlapping areas of wrapping paper. For surface area, we want to cover all the surfaces. For lateral area, we leave the top and bottom uncovered. We can think of volume as the amount of space inside the object. If we're using our present scenario, if we're wrapping a box, it's the space inside the box. When we're talking about all of these different calculations, we're going to use the notation A with a subscript L to denote lateral area, A with a subscript S to denote surface area, A with a subscript B to denote the area of the base. P with a subscript of B indicates the perimeter of the base, S indicates the slant height, H indicates the height, and R indicates the radius. Let's consider this shape. In this case, the base are actually the two triangles that are on the ends. So the lateral area is equal to the perimeter of the base times the height. The surface area is equal to 2 times the area of the base plus the lateral area. The volume is equal to the area of the base times the height. In the case of a pyramid, the lateral area is equal to the perimeter of the base times the slant height divided by 2. The surface area is equal to the area of the base plus the lateral area. The volume is equal to the area of the base times the height divided by 3. A cylinder is like a prism, but it has a circular base. In this case, the lateral area is 2 times pi times the radius times the height. The surface area is equal to 2 times the area of the base plus the lateral area. The volume is equal to the area of the base times the height. For a cone, it's again similar to a pyramid, but this time with a circular base again. So the lateral area is equal to 2 times pi times r times the slant height. The surface area is equal to the area of the base plus the lateral area. The volume is equal to the area of the base times the height divided by 3. For a sphere, there is no lateral area for a sphere. There is, however, a surface area, and that is equal to 4 times pi times the radius squared. The volume is equal to 4/3 pi times the radius cubed. So I want to take just a moment to explain slant height very specifically. It's fairly obvious in the case of a cone. The slant height is the distance from the peak of the cone down to the edge of the base. And it's really the same no matter where you measure it on a cone. It's always going to be the same distance. However, in the case of a pyramid, it's a little bit different. In this case, it's the distance from the peak of the cone to the center of the base of one side. It doesn't matter which face you use, it's going to be the same in all cases, but it has to be that measurement. What it is not the tip down the edge. So it's not from the top to the bottom on the edge. It has to be from the top to the center of one of the edges of the base. Now it's also important to look at when we're looking at the actual height of a pyramid. So the actual height of the pyramid is if you dropped a line, or same for a cone, is if you dropped a line directly down from the peak of the cone to the very center of the base. Same thing for a pyramid. You're going to drop that down right to the center of the base. Now the key thing to keep in mind is that when you're trying to find that height, you need to form a right angle triangle with that vertical line that gives you the height, goes from the center of the pyramid to the center of the base, and then you run a line out from the center of the base to the center of one of the edges. That's going to form a right angle, and that distance A is going to be exactly 1/2 this distance. So if we called this z, so that distance of the edge of the base, then that distance a is going to be equal to 1/2 of z. Because that red line, the slant height, divides the base. It lands exactly in the middle of that edge. So once you have that information now, if you have the slant height, then you can use that information to use Pythagorean theorem to calculate the height. So in that case, a squared plus h squared is going to be equal to s squared, which you can then solve. If you have s and a, you can then go ahead and solve for h. So when you rearrange the Pythagorean theorem, you end up with h is equal to the square root of s squared minus a squared. Let's try an example. Determine the lateral area, surface area, and volume of each of the following figures. Remember, this is a sphere, and for a sphere, there is no lateral area, so we'll start with the surface area. The equation for the surface area said it's 4 times pi radius squared. So 4 times pi times 2 squared, which is 4 times 2 squared is 4, so it's 16 pi. And if we multiply that on our calculator, we get 50.27. Calculating the volume. Volume is 4/3 pi r cubed. 4/3 times the radius cubed, which is equal to 32 divided by 3 pi. And if we work that out on our calculator, we end up with 33.51 cubic units. No, cubic centimeters. And our area I should have identified as centimeters squared. Part B. Looking for the lateral area first of all. The lateral area is 2 pi times the radius times the slant height. 2 pi times the radius, which is 13, and the slant height we're given is 30. Multiplying that out, we get 2,450.44 units. Now the surface area, we take the area of the base and we add it to the lateral area which we just found. The area of the base is just the area of the circle, which is pi r squared plus 2,450.44. And if we multiply that out and add it together, we end up with 2,981.37 units squared. Finally, calculating the volume. Volume is equal to the area of the base times the height divided by 3. Area of the base, pi r squared, times the height is 27. Pi r squared, pi times r squared is 13. And if we work that out, we get the volume is equal to 4,778.36 cubic units. So we've got a regular hexagon. Let's start with the lateral area. So we need the perimeter of the base times the height. So let's get the perimeter of the base first of all. We know we've got each side is a length of 8, and there are 6 sides. So we have a perimeter of the base of 48 units. So the lateral area is 48 times the height, which is 9, or 432 units squared. Calculating the surface area, we're going to take the lateral area and add to it 2 times the perimeter of the base times the apothem divided by 2. So we get 432 plus 2 times the perimeter of the base, which we said was 48, times the apothem, which we're told is 6.9, dividing that by 2, 43, plus the 2's cancel out, so we just end up with 48 times 6.9, which is equal to 331.2 units. Adding those together, we get 374.2 units squared. Finally, the volume. The volume is equal to the surface area of one face, or one base, times the height. So that's equal to the perimeter times the apothem divided by 2 times the height. We've got 48 times 6.9 divided by 2 times the height of 9, which is equal to 1,490.4 units cubed. Add this to your memory aid. Try the practice questions in the workbook and check your answers against the answer key.